Unit 6, Section 4, Integration of Trigonometric Functions. Section Objectives. By the end of this session, the student will be able to integrate simple trigonometric functions. Integration of trigonometric functions. We recall the basic trigonometric functions as sine x, cos x, tan x, and their inverses as cosec x, sec x, and cot x. Now the table below shows the integrals of these basic ratios. Now if sine x is integrated, it gives negative cos x. If cos x is integrated, we have sine x. When we integrate tan x, we have ln absolute sec x. If cosec x is integrated, we have ln absolute cosec x minus cot x. If sec x is integrated, we have ln absolute sec x plus tan x. And if cot x is integrated, we have ln absolute sine x. Integration of trigonometric functions. Example, evaluate the following integrals. A, the integral into braces 2 cos x minus sine x dx. B, the integral 1 over 1 minus sine squared x dx. C, the integral sine 2x dx. D, the integral, the lower limit negative pi over 2, the upper limit pi over 2 cos x dx. Now let's look at the solution. A, we use the properties of basic integrals of trig ratios. That is, if we have the integral of 2 cos x, 2 is a constant, so you bring it out, then the integral cos x, then minus the integral sine x. But we saw in the table that if cos is integrated, we have sine. So therefore, we have 2 sine x. But if we integrate sine, it gives negative cos. So therefore, negative times negative cos becomes plus cos x, then plus c. So therefore, the integral 2 cos x minus sine x into braces dx is equal to 2 sine x plus cos x plus c. Integration of trigonometric functions. B, to integrate the integral 1 over 1 minus sine squared x dx, we use the identity cos squared x plus sine squared x is equal to 1. And making cos squared x the subject, we have cos squared x is equal to 1 minus sine squared x. Now, it implies we have the integral 1 over cos squared x dx. But we learned that 1 over cos is sec. And therefore, 1 over cos squared x can be written as sec squared x. That is the integral sec squared x dx. But in differentiation, you saw that when tan is differentiated, we have sec squared. And since integration is the reverse of differentiation, when we integrate sec squared x dx, it gives tan x plus c. C. We let u to be 2x so that our du over dx is equal to 2. And making the x the subject, we have the x to be du over 2. Now, if we replace 2x with u and dx with du over 2 in the integral sine 2x dx, then it gives the integral sine u times du over 2, which is equal to half the integral sine u du. But we know if we integrate sine, it gives negative cos. Hence, we have negative half cos u plus c. Now we replace u with 2x, which gives the integral sine 2x dx equals negative half cos 2x plus c. Now D, for us to integrate the definite integral, the lower limit negative pi over 2, the upper limit pi over 2 cos x dx, we integrate the function cos x dx and put in the limits. So if cos x is integrated, we have sine x. So we put the upper limit pi over 2 into sine x minus we put the lower limit negative pi over 2 into sine x, which gives sine pi over 2 minus sine into braces negative pi over 2. Now sine pi over 2 is the same as sine 90, which is 1. And minus sine negative 90 is negative 1 times negative, which is plus. So which gives 1 plus 1, and that is 2.